This is the default state of the internet. Browsers are passive clients, forced to execute and render code exactly as an external server dictates. To gain supremacy over this cycle, we have to look at interception. By weaponizing local APIs, a browser can intercept and filter incoming data packets before they ever reach the viewport. We are deconstructing the architecture of a browser modification tool designed to reclaim this runtime control. This system operates across 4 primary browser subsystems: the CSS rendering pipeline, the document object model, the web audio graph, and local cryptographic storage. By manipulating these specific layers, the extension executes 30 distinct subroutines to manage how data is presented. Effectively managing your digital workspace requires treating the browser as a filtration engine that evaluates data before it ever appears on screen. The first defense is the network layer, terminating media requests to preserve bandwidth. When permitted, dynamic CSS injection mathematically distorts elements into a smart blur or pixelation filter. High contrast controls use similar logic, flipping colors or stripping saturation for a grayscale viewport. Selective access is managed through a dynamic CSS class. This triggers a hover reveal only when the cursor physically intersects a hidden element's bounding box. This rendering architecture maintains strict separation between media types. HTML5 videos and static DOM images are routed through independent logical toggles, allowing for granular control. If visuals are blocked entirely, a text alternatives toggle scrapes the HTML alt text and injects it directly into the layout so the context of the page remains intact. Using math within the CSS rendering engine allows for visual privacy that is integrated directly into the browser's native layout process. To secure text, we move into the document object model to manipulate the inner HTML. Seeded text spoofing reorders the internal characters of a word while keeping the first and last letters fixed, creating gibberish to observers while remaining readable. To prevent reading fatigue, a deterministic spoofing seed ensures a specific word always hashes into the exact same scramble. And with dynamic DOM support, mutation observers scan for newly loaded text nodes, instantly applying the scramble algorithm as they appear. DOM manipulation overrides site-specific event listeners. This allows the system to force right-click and copy functions on sites that attempt to disable context menus. Securing a dynamic text environment requires this type of real-time runtime interception to maintain control over the data. On the audio layer, the extension intercepts media tags before they can execute. This allows it to permanently prevent autoplay, stopping the data stream at its source. If playback is initiated, background media is auto-muted, ensuring streams begin silently. To manage volume, audio routes through a dynamics compressor node. This stable volume engine mathematically squashes loud spikes while boosting quieter signals for consistent output. By inserting biquad filter nodes, the system applies custom audio EQ profiles, letting the user override the mix with dialogue boost or bass cut. Routing signals through the Web Audio API treats the audio track as a programmable signal, allowing for real-time mathematical adjustment of the output. Beyond data manipulation, the system requires a method for data denial. Universal password protection creates a local vault to secure the browser interface. This diagram shows the master password being converted into a local SHA-256 hash. This cryptographic process allows the system to authenticate the user locally without needing to ping an external server. When this encrypted state is active, the system triggers a browser lock screen overlay, blocking tab visibility until the password is provided. Users can also define specific domain lock protection. This targets high-sensitivity web addresses, executing the password overlay only when those particular hostnames are queried. This local cryptographic layer ensures the browser operates as a closed loop, requiring authentication for every session without relying on external servers. This 3D diagram shows the crosshair click selector tool, which modifies the UI layer to allow for precision DOM element targeting. Once an image is selected, its internal data payload is packaged and routed to a multi-engine reverse search router. The Search All launcher uses background logic to dispatch the formatted query to 3 different visual databases at the same time. To bypass firewalls, base64 image upload handlers convert data URIs into local blob files, allowing the search to proceed even on sites blocking hot linking. A lazy load and URL bypasser parses the DOM tree to strip away low-resolution placeholder code, identifying and extracting the true high-resolution source URL. A smart URL shortener engine condenses links into minimal text. An organized history log tracks the last 20 entries. An instant QR code generator draws a scannable canvas element. While CSS and DOM obfuscation provide a defense, these extraction tools ensure the user maintains a frictionless workflow. Managing 30 distinct functions requires unified state management. In this architectural view, a command pulse travels through the network, DOM, audio, and storage layers simultaneously. The entire stack is bound to a single Alt+S shortcut. This allows the user to toggle the state of the rendering, audio, and DOM pipelines instantly with a single keyboard input. The active protection status is surfaced through a dynamic extension batch on the browser's toolbar, providing a constant indicator of the system state. Background service workers quantify these interceptions in real time, displaying the count of blocked or hidden media directly in the user interface. Meticulously engineering the space between a network request and the final pixel render gives the end user final authority over how they experience the web.